In the previous video, we set up a separator, vapor-liquid separator, in order that we can remove the lighter hydrocarbons from the heavier hydrocarbon. The heavier hydrocarbon in this case being our pseudo component that we created to boil at 550 degrees. Here we can see the remainder of the components. In the next stage, we will want to further separate these light components. To do this, we can drop the temperature back to a temperature at which some of these components will condense. We utilize a cooler to do this. As before, double-clicking on the cooler brings up its form, and under the Design Connections page, we can add the inlet to the cooler, in this case VAP, and we can add an outlet, which we shall call VAP-1. Note, a message comes up that we require an energy stream, and we can specify an energy stream as C-Q for the cooler energy. Next, we are told that we need to specify one more piece of information for the cooler, which is its delta P. We can go to the Parameters tab, and we can specify a delta P of 0.5 atmospheres. We still have one unknown, which is either the temperature exiting the cooler or the duty. We know we have an unknown because the icon is yellow and the bar is yellow. One must remember that you can have either separation, you can define a stream either by its temperature and pressure or its vapor fraction and pressure. Should we specify a vapor fraction in this case of 60% vapor, a temperature will be calculated for us at minus 10.01. Here we can see the composition of that stream and its vapor fraction. For this example though, we will not specify the vapor fraction but the temperature, 20 degrees Celsius. Our cooler's duty will be calculated, and this is the energy removed or must be removed to drop from 500 degrees Celsius to 20 degrees Celsius. Note, at this temperature, the vapor fraction is 62.46. And in this mixture we have water, we have propane. This mixture can be separated now into a vapor stream, a light hydrocarbon stream, and a heavier stream, or a light liquid stream and a heavier stream. We can utilize a three-phase separator to do this. If your palette is not there, you can re-access your palette via the View menu, Model Palette. We will now configure the three-phase separator by adding the outlet of the cooler as the feed to the separator, and making sure to create a new stream for the liquid, the light liquid and the heavy liquid. Again, we could have specified an energy stream and changed the temperatures on the outlet of the three-phase separator. Now we can see that this stream should contain only the gases that were present and would have an associated light liquid stream, which should contain very little water and mostly hydrocarbon, and a heavy liquid stream, which would contain mostly water and very little hydrocarbons. This is an operation that is done in the petrochemical industry, because there may be times when we want to remove the water to avoid freeze out in our system or poisoning to our catalysts. Also corrosion. In the next video, we will look at setting up a basic reactor. Here we will look at equilibrium reactions, kinetic reactions, and simple conversion reactions.